In this lesson, we will learn what branched alkanes are and how to name them. By the end of this lesson, you should be able to name branched alkanes with up to 8 carbon atoms in the main chain and write the shortened structural formula of branched alkanes. You should also be able to draw the full structure from the name or the shortened structural formula. Let's imagine for a moment that we take a linear alkane, such as butane, with 4 carbon atoms. Every carbon atom has to have 4 bonds, so for a linear alkane, all of these bonds would have to be to hydrogen. But they don't have to be. They could instead be another carbon atom. Carbon atoms on the side of the molecule are called branches, and these alkanes are called branched alkanes. Remember how we wrote the shortened structural formula for propane? The first thing we do is we split up the carbon chain into individual carbon atoms and then write down the formula for each individual section. So we'll start with the first carbon atom here. It has 3 hydrogen atoms attached to it, so we write down CH3. The second carbon atom has 2 hydrogen atoms attached to it, so we write down CH2. And the third carbon atom has 3 hydrogen atoms attached to it, so we'll write down CH3. If we add a carbon atom onto the central carbon, we have a branch. I'm going to highlight it here. In order to add in these branches into our shortened structural formula, we put them in brackets after the carbon to which they are attached. So let's work through this chain. First of all, we will split our carbon chain up into atoms as usual. The first carbon atom here has 3 hydrogen atoms attached to it, so we write down CH3. Our second carbon atom here just has 1 hydrogen atom attached to it, so we write down CH. Now we'll consider our branch because it's attached to this carbon atom. So our formula of our branch is CH3. They're shown in brackets after the carbon it's attached to, so that's this carbon atom here. So what we'll do is we will write CH3 in brackets. Finally, we'll consider the last carbon atom in our chain, which has 3 hydrogen atoms attached. So it's CH3. Let's work through another example. The first thing that we'll do is split our carbon chain up into individual carbon atoms. Now let's consider each section. The first section here has 1 carbon atom and 3 hydrogen atoms. CH3. Let's look at the second carbon. Let's ignore the branch for the moment. What we have is CH. Now let's consider our branch. Remember, branches are placed in brackets after the carbon they are attached to. So we have a CH3 group, and we'll put that in brackets. Let's move on to our next carbon. This one is CH2. And finally, our end carbon is CH3. What happens if we have more than one branch? Well, let's start in exactly the same way as before. We will split our carbon chain up into individual carbon atoms. The first carbon is CH3. Our second carbon is just a C on its own, and we're going to put our branches in brackets. We have 1 branch up here, which is CH3, and we have a second branch down here, which is also CH3. Because these branches are the same, we can put a 2 after the group. And then we'll carry on. The next carbon is CH2. And the final carbon is CH3. Let's work through a final example. So we'll start in the same way as before. We'll split our carbon chain up into individual carbon atoms. Now note we've got two different branches on this molecule. We've got a branch here, which is CH3, but we also have a branch down here. Now the formula of this branch is not CH3, it's C2H5. 1, 2, 3, 4, 5 hydrogens. But let's just work through our chain from beginning to end. So we'll start with the first carbon atom. The formula for that part is CH3. Our second carbon is CH, but we mustn't forget to add on the branch. Branches go in brackets, remember. Let's move on to our next carbon atom. This one here, again, CH. And we'll add on our branch, but our branch is this time C2H5. It goes in brackets. Let's move on to the next carbon atom. This part is the formula CH2. And finally, the carbon on the end. CH3. And there we have our shortened structural formula.